Good evening to all. Welcome to Infosys Coding Training, Day 5. Hope you are all doing well, preparing for 18th January exam. So, how is your preparation? How is your preparation going on? Okay, so aim at solving one question with complete test cases passed. Okay, so then you have fair chances of getting interview call. Okay, next day immediately on 19th. Okay, so 18th night you will get a mail for interview. 19th you will have interview, that also in person. So thank you, Kader Babu. If you are really preparing well, okay, so definitely you follow the topics which I mentioned in my previous videos. Okay, so solve at least 10 problems on those topics, like greedy method. Okay, so from lead code or code forces. So what are the topics to be prepared? So at least one question completely with all test cases passed. I explained in my first video. Okay, so just check out day one video. There I explained. Okay, what are the chances of getting interview call? If you watch day one video, then you will get some idea. Okay, so that you can focus on those tips. Okay, so shall we proceed? So today we'll try to solve one more problem. So this is the question given in 2026 examination. So hopefully my video is covering the screen. So let me switch off the video. So this is the question uh, given. Okay, so in Infosys examination. So let us proceed with this question and how to solve this question. Okay, right. So what is the question? You are given an array, okay, of integers. ARR is the array name, of size n and an integer k. Okay. So once again, I am repeating. So friends, Infosys likes questions on arrays most. Okay. So arrays, strings, related questions. So definitely there will be one question uh, related to arrays and strings. Okay. So then there will be one question on greedy approach. Okay. So greedy algorithm. Then one question on a dynamic programming. So these topics you prepare because you have very short time. So solve 10 questions at least on these topics before you appear for your examination. Okay, so then you will get some confidence and uh, fair chances of getting interview call. Okay, so let us proceed with today's question. So we are given an array of integers, okay, whose size is n, and say integer, one more integer k is given. Okay, so you are allowed to perform at most k swap operations. Okay, so what this k indicates? So the number of swap operations that we need to perform on the array, given array. Okay, so you need to perform the k swap operations. Okay, so I told you need to understand each line very clearly. Okay, so here you should look at these type of prepositions. Okay, so these kind of words. See here, allowed to perform at most k swap operations. Okay, so it is given as at most. At most means you should perform only maximum of k operations. Okay, so you can also perform a less than or equal to k operations, but your number of swap operations should not be greater than a k. Okay, so this you should clearly understand from the problem. Okay, so generally people in hurry, they just look at this k swap operations, so they understand that they need to perform all the k operations. Okay, so they think that they need to perform k operations, compulsory k operations. We need to k swap operations we need to perform on the uh, array. Okay, that's how uh, your understanding. Okay, so if we understand the problem in that way, then uh, we will make a mistake while writing the code. Okay, so that's why we should look at these kind of words very carefully. Okay, so at most k, whenever we say at most k means it can be less than or equal to k, but it should not be more than a k. Okay, so hope you understood this sentence. Okay, right. So in one swap operation, you can choose any two indices I and j, and swap array of I and array of j. Okay, so these two elements you can swap. Okay, so you can choose any index here, array of I and array of j. I and j values, you can choose any array I and j values, and you should swap these two values. Okay, so this is in one swap operation, you should swap only two elements. That's it. Okay, then after like this, how many swap operations you should perform? K, at most k swap operations. That means less than or equal to k swap operations based on the requirement. Okay, so after performing at most, again it is given, see here, at most k swaps. Okay, so that is meaning is that it is not required to perform exactly k operations. Okay, so based on your uh, test case, you can also perform a less than a k swap operations. That is the meaning of this. Okay, so after performing at most k swaps, choose a non-empty contiguous subarray. So you will get a non-empty contiguous subarray, because anyhow the array contains elements, no? So just you are interchanging the elements within the array. So you will get a non-empty contiguous subarray. So then what you need to do? Compute its sum. So you need to calculate the sum, that subarray sum you need to calculate. Okay. So what is our task? Your task is to return the maximum possible subarray sum. Okay, so maximum possible subarray sum that can be obtained. Okay, so after performing at most k swap operations, okay, so you find out it is related to yesterday's problem. Okay, so maximum possible subarray sum you need to. Okay, so that means you need to find out a subarray whose sum is. Okay, so a subarray you need to find out whose sum is a maximum. Okay, so the sum of elements present in this subarray should give you the maximum value. That subarray you need to identify in the given array after performing the k swap operations. Okay, so this is our problem statement. Okay, so hope you understood the problem statement. Yes or no? Any doubts in this? So you try to work problems related to this maximum possible subarray sum. Okay, so work out problems using Kadane's algorithm. Okay, so if you understand Kadane's algorithm, so there is a slight modification of Kadane's algorithm. Okay, so and all those related to maximum possible subarray sum only. Okay, so let us work out this problem. Okay, so after uh, getting some understanding about this problem. Okay, so now we need to work out. So test cases, uh, I haven't get any test cases for this. So let us take some our own test cases. Then let us work out the problem here. Okay, so first let us take one array. Okay, so assume that this is our array containing four elements. Okay, so what are those four elements? Say 1, 1, minus 10, and 20. Okay, so then k value is 1. K value is 1. That means at most you can perform a one swap operation. You can perform one swap operation. Okay, if this is the given array. Okay, so if you perform at most one swap operation, then you need to find out the maximum subarray sum you need to find out. Okay, so which element we can swap from this so that you will get a maximum subarray sum. Okay, so first let us analyze this without swapping. Okay, so what is the maximum subarray sum? For example, if I say k is equal to 0, okay, so that means number of swaps is equal to 0. Okay, afterwards I'll explain k is equal to 1 what we need to do. Okay, so if number of swaps is equal to 0, okay, so what is the maximum subarray that gives the sum, maximum sum here? Okay, so from this, each element forms a subarray. Yes or no? Okay, so I am writing all the subarrays here because you need to understand all these things. Okay, so what are all subarrays possible here? Okay, so each element is a subarray. Okay, so I am just writing here. This one is a subarray. Okay, so then this second one is a subarray. Then minus 10 is a subarray. Then 20 is another subarray. Okay, so then combination of these two elements. Okay, so then 1 is another sub array. Okay, so then 1 minus 10 is another sub array. Then 1 comma 20 is another sub array. Okay, right? So then what are other sub arrays? Now combination of three elements. Okay, so this two elements combination you should form with all other elements. Okay, so then they can be in this form. Okay, so three elements now. 1 minus 10, this is one more sub array. Okay, then 1 then 20, this is another sub array. Okay, but these are sub arrays, but in this uh, maximum possible sub array. Okay, so that in our problem, as per our problem, so if you look at this 1 and 1 minus 10. Okay, so even though it is a sub array, but the elements should be contiguous. In this sub array, the elements should be contiguous. As per mathematics, this is a sub array, no doubt. Okay, but from our context, this cannot be a sub array. This cannot be a sub array. Okay, because the in sub array you should select a sub array such that the elements should be contiguous from this main array. Okay, so that's why we write all subarrays based on this property. Okay, so this also you should understand. Okay, so let me remove these things, and now as per our contiguous property, we'll write only those subarrays. Okay, so which are contiguous, right? So the very first one is each element forms one subarray. Okay, so this is uh, supporting this or satisfying this contiguous property. Okay, so then first two elements, one sub array. Okay, so then next two elements, another sub array. These two elements, another sub array. Okay, so 1 comma minus 10. This is another sub array. Okay, so then next two elements, another sub array, minus 10 comma 20. This is another sub array. Okay, so then the first three elements can be one sub array. Okay, so 1 1 minus 10 can be a sub array. Okay, so similarly the next three elements can be another sub array. So 1 minus 10 comma 20, this is another sub array. Okay, so next all the four elements are also form a sub array, minus 10 comma 20. Okay, so these are all possible sub arrays for this. Okay, now if swapping is not allowed on this, okay, so which sub array gives the maximum, you have to select one sub array whose sum is a sum of elements in that sub array should give you the maximum value. Okay, so now this is giving the value 1 1 here, this is minus 10, this is 20. Okay, so till now just we'll store this maximum sum value as a 20. Okay, so that means this sub array is giving a maximum 20, and this is 2 less than this. Okay, and this is minus 9, not this is 10, not. Okay, this is also not contributing, and this is also not contributing. So then this is also not contributing. Okay, so then which sub array is now maximum sum having 20. Okay, so if no swapping is allowed, okay, so then the sub array containing the element 20 is the maximum possible sub array that gives the sum. Okay, so this 20 you should print. Okay, right, now we'll take the same array. Okay, so now with the swapping operations allowed on this. Okay, so how the answer changes, just look at here. 1 1 minus 10 and 20. Okay, so k is equals to 1, k is equals to 1. Okay, so that means one swap operation, at least at most one swap operation perform. Okay, so then find out the maximum possible subarray. Okay, right, so which one we can swap, for example, if I swap this to this place. Okay, so that means 1 here and 10 here. Okay, so 1 here and 10 here. So then what I get here, this becomes minus 10 and this becomes a 1 here. Okay, so if I select maximum possible subarray, I can select this one. So it gives 21 square, 21 it gives. Okay, instead of that you find out, is there any other way, which gives the maximum value. Okay, so if this is minus 10. Okay, so instead of this, okay, so what we do is, now if we can swap these two elements. Okay, so in the problem it is given that you can select any I and j values. Okay, it is not compulsory that only side by side elements you should swap. No, you can swap any two elements from within the array. I and j values can be anything here. Okay, so in this case our I and j values looks like this. Okay, so I value is j, I 0 and j value is 2. Okay, so now I am swapping a of I and a of I means a of 0 and a of 2 values I am swapping. Okay, so if I swap these two, what happens? This becomes minus 10 and this becomes a 1 here. Okay, so this becomes a 1 here. Okay, so then if I select this sub array, okay, so if I select this sub array, now this is giving the maximum sum value 20 plus 2. Okay, so 22, the answer is 22 that is giving. Okay, so this is a one test case. Okay, so then with one swap operation allowed on this, then this is the maximum possible sum sub array whose sum is 22. Got it? Right, so we'll take one more test case. Okay, so first we need to understand test cases. Okay, so then you can identify the logic from these test cases. So let us take one more array. So let me take one more array, say for example minus 10, 5, 5, okay, then minus 10. For example, if k is equal to 0, k is equal to 0, okay, so that means no swap operations are allowed on this. No swap operations are allowed on this, okay, so now find out the subarray whose sum is maximum. Okay, so which subarray whose sum is maximum? Now this is the subarray whose sum is, okay. So here sum value is equal to 10. Okay, so this is giving the maximum value. Okay, so if you select the first two, it will be 5 only. If you select the first three, okay, it becomes a 0. Sum becomes a 0. Okay, or if you select the next three, again sum becomes a 0. Okay, if you select these two, sum becomes, so only these two, the middle two elements are contributing a maximum sum value. Okay, so then this is the sub array, maximum sub possible sub array, we can say. Got it? Okay, so let us take one more example. So this time we'll take 5 elements. Okay, so let 2, 3, minus 1, 4 and 6. Okay, so then if k value is equal to 1 in this case, k value is equal to 1. Okay, so then what is the maximum possible subarray sum? Okay, so which one we can swap here? So we can swap this 3 and 2, because always remember negative numbers, they does not contribute to maximum sum. Okay, so always you look at the least number and swap the least number with the highest remaining numbers. Okay, so in this case, that means if you swap 3 to here, then it contributes to maximum sum here. Okay, so then 3 comes here, then minus 1 comes here. Okay, so then this becomes the maximum sum sub array. Okay, so 6 plus 4, 10, 10 plus 3, 13 plus 2. Okay, so here in this case, sum value is 15. Sum value is 15. Okay, so this is our problem. Okay, so having known this problem, understand the logic of the problem. Okay, so now we need to work out in-depth logic. Okay, so this is uh, just a broad view of the problem solution. Okay, so now in depth, how, since this is visible to us, you can say that 2, 3, 4, 6 forms the subarray whose sum is maximum 15. Okay, so since we are uh, looking at this subarray, okay, so through our eyes we can identify this. Okay, but given this array to a program, the program should identify this with which element it should swap, so that you will get this maximum sum value. Okay, so for that you need to devise the logic. Okay, so let us go to the first problem. We'll take the first problem and try to understand how to arrive at the solution. Okay, so 1, 1, minus 10 and 20. Okay, so I'll draw the array here. This is 1, 1, minus 10 and 20. Okay, so clearly you write the array here with index 0, 1, 2 and 3. So what we required initially, we required the maximum sum. Okay, so maximum sum initially you consider 0, or you can consider a least value, that is minus infinity you can consider. Okay, or 0 you can say here. What else we required? Okay, so how to arrive at the solution? Okay, so you should start working from the first element onwards, then slowly finding the sub array whose sum is maximum, keeping the number of swaps in mind. Okay, so in this case k value is 1. We'll take the k value as 1. That means one swap allowed here. One swap allowed. Yes or no? Okay, so first we'll take this. That means you need to each element forms a subarray, I said. Okay, so for each element as a subarray with other elements, you should choose the combination. You should choose the combination such that you will get to maximum sum value. Okay, so how to proceed this? Okay, so first I choose this. Okay, so it is just like increasing the window. It is related to sliding window problem. Okay, so whenever you say maximum sum sub array, okay, so it is just a concept of a sliding window. You need to start a window with size 0 and slowly you should increase the window with one element, then with two elements, with three elements, so that this sliding window gives you the maximum sum. Okay, so this is how it can be solved here. Okay, so let us start our window. Okay, so window represents the sliding window. Okay, so that means the sub array. Okay, so this represents the sub array. Okay, so instead of a window, I take a better name called as a max sub array. I call it as a max sub array. Okay, so I start with the first element. I consider the first element as the max sub array. Okay, so then remaining elements. Okay, so I call them as something like others. I call them as others. Okay, so what are other elements? These other elements. Okay, so 1 minus 10 and 20 are other elements. Okay, so this I am considering the sub array now. Okay, so remaining elements are these three elements. So what we need to do is we need to swap. Okay, so from this we need to swap, say for example 1 minus 10 and 20. We need to swap a highest element from this others in this maximum subarray so that your sum should be maximum. Yes or no? Okay, so this is related to greedy approach. So we should be greedy. Okay, so it follows sliding window concept and a greedy approach. Okay, so always greedy that swap from other elements of the sub array. Okay, so the maximum highest element into the maximum sub array so that it contributes to maximum value. It contributes to maximum value. Okay, so for this what we need to do is we need to arrange them in a descending order. That becomes easy, so that always the highest element will be in the first place. Okay, so now this you should use in your coding logic. Okay, so instead of searching for a highest element in the remaining other elements, so what you can do is you can just arrange them in the descending order. Okay, so that highest element is available in the first place. So this is 21 and minus 10. 21 and minus 10. Okay, so I got this maximum subarray and others value I got. Okay, so then what I do, I find out the current sum here. Okay, so current sum and max sum values we required. Okay, anyhow max sum I have here. Okay, so current sum always represents this max sub array elements, sum of the elements present in this sub array. Please remember, in this sub array. Okay, so what is current sum? Previously it is 0 and now it is 1. The current sum is 1 now. Okay, so then after dividing this array into two sub arrays and keeping this second others in a descending order. Okay, so now what you need to do is you need to check whether the element present in the max sub array is greater than this less than this first array. Okay, or others contains greater number, okay, than this element in the max sub array. Okay, so since here 20 is greater than 1. Okay, so I am looking at this 20 greater than 1. What you need to do is you need to swap these two numbers. Okay, now you can perform one swap operation. K is equal to 1 allowed now. Now you can perform one swap operation. Okay, so these two elements you can swap now. Okay, so if you swap this, what happens logically? I'm saying here. Okay, so 20 comes here. Okay, so 1 comes here. Assume that 1 comes here. Okay, so then our current sum value should be now this 20. Okay, so how you can get the current sum value? Now the current sum value, okay, so it should be, previously it is 1. Okay, so what you need to do now, you need to add the element which you are swapping. Okay, so that means add 20 from others and subtract the value from a max sub array. Okay, so then this gives the value here. This gives the value 20 here. This is our current sum value. Okay, so current sum, this is 20. Okay, so that's it. Only one swap is allowed now. One swap is allowed now. So then what is the maximum subarray sum? So current sum is 20 and maximum sum is minus infinity. Now you find out, you update the max sum value. Okay, so now the max sum will become maximum of these two. Okay, so now the max sum value becomes, okay, so I'll write here. We used the uh, logic yesterday's in yesterday's problem. Okay, so it is nothing but max sum is equal to max of a previous max sum comma current sum. Okay, so it is minus infinity comma 20, it is 20. Okay, so now this time our max sum value becomes a 20. Good. Okay, so now you increase the window size. Previously the first element only you assumed as a max array. Okay, so then again you go back to array. Now you take the first two elements as the sub array. Okay, so again we repeat the same process. Right, so now our array is now 1 1. Okay, so these two elements I am considering now. These two elements. Okay, so this is my sub array I am considering. I said sub array should be contiguous, I said. Okay, so this is my sub array. 1 1 is my sub array. Okay, so if this is my sub array, what are other elements, remaining elements? Minus 10 and 20. Okay, but this should be arranged in descending order, I said. Okay, so better you write in descending order. Minus 10 and 1. Okay, and even this max sub array should be written in a ascending order. Ascending order. Okay, so why? If you arrange this in ascending order, so you will get the least element in the first position. So you will get the least element in the first position. And if you arrange this in a descending order, okay, in descending order, what is the advantage? You will get the highest element in the first position. Then you can interchange these two so that your sum value will become maximum. Sum value becomes a maximum. Okay, so for that we are doing this. Right, now this is our maximum subarray. Now find out, update the current sum. Current sum is sum of all the elements in this subarray. Okay, so it is 1 plus 1 is 2. This is my current sum. Okay, so now check whether the element in others, first element in others is greater than this first element in the max subarray. Yes, 20 greater than 1. Yes. Okay, so now you interchange. So that means 20 comes here and 1 comes here. One swap only allowed. Okay, so after swapping these two elements, now update the current sum value. Now this is our new subarray. So update this. 20 plus 1 is 21. Current sum will be 21. Okay, so then update the maximum sum. Maximum sum is previous maximum sum. Okay, so maximum of previous is 20. 20 comma 21. Now this becomes a 21. Got it? Okay, so then increase the window size. Okay, so now your window size with three elements. Now you take three elements. So 1 1 and 10. So I am taking this, and you should arrange them in ascending order, I said. Okay, so then minus 10 comes here, 1 comes here, 1 comes here. Then remaining elements means only 20 comes here. 20 comes here. Okay, so then update the current sum. Current sum is minus 10 plus 2 here. So this is minus 8. It becomes a minus 8. Okay. So then check out first elements in this. Okay. So 20 greater than minus 10. Yes. So interchange these two. Okay. So then 20 comes here, minus 10 comes here. 20 comes here, minus 10 comes here. So now update maximum sum. Okay, so to update this current sum value, now you got new sub array now. So current sum value, because only one swap allowed, that's it, you cannot make any more changes here. So 20 plus 2, so now the current sum becomes 22. Update the maximum sum value, so it is 21 comma 22, this becomes 22, this becomes 22. Okay, so let me write this as 22. Now this becomes 22. Okay, so again repeat with the next element. So you have to follow the same procedure, check out whether it is working fine for all the elements. Okay, other categories also. Okay, now see here, so what is our array here? So now four elements forms this one. Okay, so that's why you need to take the subarray containing all the four elements, and you should arrange them in ascending order. I said no, so it is minus 10, 1, 1 and 20. Okay, so then others contains a empty array here. Okay, so empty array, so that means you cannot perform any swap operation. Okay, so that's why it is given at most. In this case, you cannot perform a swap operation. Okay, so then what is the current sum in this case? 20 plus 2, 22, 22 and minus 10. So it is 12. It is 12. So then maximum sum is 22 comma 12 is 22 only. So it won't change. That's it. Okay, so for one iteration, you got this. Okay, so then you have to keeping this first element, starting with the first element. Okay, so then slowly we increased the window size. Okay, so then two elements. Initially, our window size is 1. Then window size 2 we took. Then window size 3 we took. Then window size 4 elements. All the 4 elements we took. Okay, so we increased the window size and we found the maximum sum value. Okay, so then you should proceed with the second element, starting from the second element and its combinations. Okay, so then what you should do is, because all possibilities you need to check. Now starting with this element. Okay, so now my this thing sub array becomes a, now you can see here, sub array contains a 1, this one. Okay, so this one here 1, and the remaining elements means this is 1 minus 10. Okay, so you should arrange them in a descending order. I said no, so 20 minus 10 and 1. Okay, so what is the current sum value? It is 1. Current sum is 1 here. Okay, so then swap possible, just you check 20 greater than 1. Yes, swap now. Okay, so this is 20 and 1 comes here. So what is the current sum now? 20. Current sum is 20. Okay, so then maximum sum anyhow 22, no, it won't change. Okay, so then increase the size here, so 1 and minus 10. Okay, so I'm just writing here quickly, I'm going here. So this is a minus 10 here. So this is minus 10. Okay, so then 1, these two elements I am considering now, minus 10 and 1. Okay, because the next three elements may form a subarray. Okay, that may give the maximum sum. Okay, so you need to test all these cases. So remaining elements means if these two are 1 and 20, so arrange them in descending order, 1 and 20. So what is the current sum? Minus 10 comma 1 means it is minus 9. Okay, so now you swap possible. Yes, 20 greater than minus 10. Yes, so 20 comes here, minus 10 comes here. Okay, so it is minus 10. So what is current sum now? 20 plus 1 is 21. So it is 21. So update the max sum. Max sum is again 22 only. Okay, so repeat the process. So next time take the next three elements. Okay, so these three elements now you consider these three elements. So it is nothing but arrange them in ascending order minus 10, 1 and 1. Okay, so remaining elements means only 20 will present in this. Okay, so what is current sum here? Current sum is minus 8 here. Okay, so check out swap possible. Yes. Okay, so replace this 10 and here minus 10. So what is the current sum here? Current sum is 22. So update the max sum. Max sum is again 22 only. Okay, so keeping this element in mind, now we checked all possible subarrays. Okay, so like this, you should check for remaining elements. So you should increase, go to the next element. Okay, so then you should check for the next element. Okay, so now keeping this element in mind, okay, so you should work out this. So let us work out one problem. You work out completely. Okay, then only you will understand the logic, what is happening. Now we'll take this element minus 10, then others will be remaining elements in descending order. Okay, so 20, 1 and 1. Okay, so what is current sum? Current sum is equal to minus 10 now. Okay, so current sum is equal to minus 10 in this case. It is minus 10. So swap possible? Yes. Okay, so 20 comes here and minus 10 comes here. So what is the current sum value? 20. Update max sum. Max sum is 22 only. Okay, so then go to the next element, increase the window size. So this becomes a minus 10 and 20 ascending order, I said. No, so this is in ascending, this is in descending. So remaining elements means 1 1 only. So remaining elements 1 1 only. Okay, so then what is the current sum? The current sum is 10 here. 20 minus 10 is 10. Okay, swap possible? Yes, possible. So this replace with the 1 and minus 10 comes here. So what is current sum? 20 plus 1 is 21. 20 plus 1 is 21. Okay, so what is max sum? 22 only. Max sum is 22 only. Okay, so like this, if we work out, okay, so for the next element, 20 is the current window. That's it. Then remaining elements are nothing but 1, 1 and minus 10. Okay, swap possible? Not possible here. Maximum again 20 only. So then maximum will not change, 22 only. That's it. Okay, so if you go to last element, if you repeat like this, then you will get the maximum sum. 22 is the maximum sum. Okay, so if you can return this variable max sum, that gives the maximum sum value. Got the logic? Yes or no? So this is how you should work out the logic. So you should spend some time, okay, half an hour to 40 minutes in understanding the test cases and mapping input to output. Okay, so on paper manually you should get from this input whatever output is given. Okay, so that output if you can derive. Okay, so then you are understanding the logic. Problem understanding is 70 to 80%, and if you work out these test cases, so okay, so 90% of understanding of the problem you will get. Okay, so once you get clarity about the problem and the logic while working out input to output mapping, you will also derive a logic in mind. Okay, like this we said, no, some things like ascending descending order, if we arrange, then it becomes easy. Okay, so these things comes by practice. Okay, so if you work out, that's why I'm uh, telling. Okay, so practice 10 15 questions on each topic, not code. Okay, so don't practice code, practice deriving the logic. Okay, so deriving the logic. Okay, so code is not a required for this. Okay, so what you need to practice? You practice deriving the logic. Okay, so this you should do on paper. I suggest. Okay, so to work out the logic on paper. If you work out the logic on paper, then easily you can convert that into code. Okay, so let us proceed with the second test case. Okay, so we apply the same on the second test case and we will see whether we'll get this sum value 10 or not. If we are getting this, then we can convert that logic into code easily. Okay, so quickly we'll work out this. Okay, so we'll take this array. Clear understanding of the problem is required here. Okay, so what are the variables we required? Max sum value we required. So initially max sum you can take 0 or minus infinity, whatever you want. Okay, so then what other things you required? Okay, so one thing is you required two subarrays. You need to split this into two subarrays. Okay, so one is called a max subarray. Okay, so max subarray. So first we'll start with the first element as our max subarray. Okay, so minus 10 is our max subarray. Okay, so then others remaining elements forms the other subarray. Okay, so this is other subarray in descending order. Okay, so that means 5, 5 and minus 10. So then update the current sum here. Once you get this max subarray, okay, so sum of elements in this max subarray is nothing but the current sum. So your current sum you should initialize to 0. Now you update after getting this. Okay, so it is 0 minus 10. It is nothing but minus 10. Maximum current sum is minus 10. Okay, so then you check out swap possible. Yes. Okay, so then swap this. So 5 comes here and minus 10 comes here. So then update the current sum. What is current sum now? Current sum value is nothing but the 5. Okay, so it is always current sum, always sum of elements in this max subarray. Okay, so now you update the max sum value. Okay, so how you can update the max sum? Max sum is nothing but max of a previous max sum and the current sum. Okay, so previous maximum is minus infinity, current sum is 5. So then this becomes a 5 here. This becomes a 5 here. Okay, so now increase the window size. So okay, so if you increase the window size, okay, so if you increase the window size, then now it contains two elements. Okay, so minus 10 and 5. Then remaining elements means 5 and minus 10 only. Okay, so what is the current sum value here? Current sum is equal to minus 10, 5 is minus 5. Okay, so swap possible? Yes. Okay, so 5 comes here, minus 10 comes here. So then update the current sum. 5 plus 5 is 10. So current sum is 10 here. Current sum is 10 here. So then update max sum here. So max sum value is 5 comma 10 means it is 10. Okay, so just you can see here from this 5 plus 5. This is the sub array which contributing to maximum sub array, maximum sum. Okay, so this sub array from our diagram you can find out. This sub array is contributing. Now we got that same sub array here. 5 plus 5, 10 we got. Okay, so maximum sum is 10. Okay, so now expand the window. Now expand the window to 3 elements. So now your window will be expanded to 3 elements. So it is now in ascending order. So minus 10, 5 and 5. It is minus 10, 5 and 5. Okay, so then remaining elements means minus 10. Okay, so then what is current sum? Current sum will become 0. Okay, swap possible? No, not possible. Then update the maximum sum. It won't change. Okay, then again extend the window. Okay, so your window contains one more element minus 10. Okay, so others 0. No elements. Okay, so update the current sum. So current sum is nothing but minus 10. Current sum is nothing but minus 10. Okay, so swap, no swap, maximum value, max sum is again 10 only. Okay, so that means first element, taking first element onwards, then we increased the window size and we identified the maximum for the first element. Okay, then you should start from second element onwards. Okay, and slowly increase, because this may form a subarray. This may form a subarray whose sum is maximum. Okay, so here what we did from the first element means we started with minus 10. Okay, so then 5, 5 with minus 10 as 1. Okay, so then added 5. Okay, other sub array we considered, then added another 5, another sub array we considered. Okay, so then added minus 10, another sub array we considered, like this, slowly, then taking with this again. So 5, next 5, minus 10, like this you should check out for all possibilities. If you check only for one element, okay, so your maximum sum may be somewhere in the middle or at the end sometimes, like we have seen in this case. Okay, if k is equal to 0, your maximum sum is at the last position. Okay, got it. So let us convert this logic into code. Okay, so let me write the code for this. What we do is we'll define the function. We will define the function. So the function name is max sub array. Okay, so max sub array with the k swaps. Okay, so containing k swaps, like this. The function name will be given. Okay, so it contains the number of elements it is given. Okay, so n is given. What is input given here? So you are given n integer and also k value given. Okay, array is also given. Okay, so that means n value is also given to us, then k value is given to us, then array will be given to us. Okay, so these are the possible values or input values. Okay, so once you know number of elements, number of swaps and the array. Okay, so in our case array is like the one. Okay, so 10 5 5 minus 10, this may be our array. Minus 10, then 5, 5 minus 10, this is our array. Okay, so what is n value here? N value is 4. Okay, so assume number of swaps allowed. Okay, so number of swaps allowed 1 or 0 for this. Okay, so maximum sum problem. Okay, so if number of swaps allowed are 0, okay, so k is equal to 0, then maximum sum is this one. Maximum sum is this one. If number of swaps is equal to 1, 1 also, you will get the maximum sum as a 10. Okay, so maximum number of swaps is equal to 1 means your swap operation should not be exceeding 1. Okay, so it can be 0 sometimes. Okay, so k value you can take 1 or 0, no issue in this case. So 1 if you take. Okay, so what we need to do? What we need to do, as I said, what we required, just you find out what are all variables we required. Okay, so those variables you define here. Okay, so for the very first thing is you require the max sum. Yes or no? You required max sum variable. So define this max sum value. Okay, so this you can define in Python. Instead of initializing it to 0, you can just initialize it to minus infinity. Very smallest value you take. Okay, very smallest value you take. Okay, so then that will be initialized to minus infinity. Maximum value will be initialized to minus infinity. In mathematics, we show like this minus infinity. Okay, but this minus infinity is very smallest value, near to minus infinity, stored in a variable called max sum. Okay, I'm just denoting with the symbol here, minus infinity. Okay, assume that. Then what else we required? What else we required? Okay, so That means we require the uh, current sum. Okay, so current sum directly you can initialize. Okay, initialize the current sum value to 0 because you have not yet started. Then you can start a window from first element onwards. Okay, if it's 0 1 2 and 3. Okay, so you should run two loops here, one loop for each element. Okay, so considering each element as a sub array and expanding that window. Okay, expanding that window, then you should start here, then expanding the window. Okay, then you should start here, then expanding the window, like this. So that means you should run a outer loop for all the elements of this array. Okay, so I'm running this for I. Okay, so for I in range of n, for I in range of n. Okay, so this loop runs four times. What are I values? In this case, I may get values like 0 1 2 and 3. Number of elements are 4 no in this case. So then it gets the values 0 1 2 3. So for each value you should run this. Okay, so that means I is equal to 0 means now we are considering the first element as our sub array. Then slowly we expand the window size. Okay, so that is a outer loop we should run here. Okay, so once after getting the outer loop, what you need to do? Okay, so you should divide this into two sub arrays. Yes or no? You should divide this into two sub arrays. Okay, so one is called a max sub array, one is called max sub array. Okay, so how you can divide this max sub array? And it should be in ascending order. Okay, so for that you have a function called as a sorted. Okay, so then you should extract the part from main array by using slicing operation. Okay, so how you can get here sub array? So starting from I up to which position you should. Okay, so this you should see here, first element. After getting the first element, okay, so you should expand it to j. That means inside the loop you should run one more loop. For example, minus 10 is first. Then you should, remaining elements are 5, 5, minus 10 we said, no? So you should add each element so that it forms a new sub array. Minus 10 is one sub array. With this, you should check all these elements. Then you should add 5, then form another sub array. Then you should add next element, add another sub array. Then add minus 10, then add another sub array. That means for this element, you should add each of these elements so that your window will be expanded. Your window will be expanded until it completes all the elements in this. That means it reaches to the end of the array. Okay, so for adding each element, you require one more loop inside this. Okay, so that we will do here for j in a range. Okay, so for j in range, so what should be the range here? It should start from I to n. Okay, so because as I value increases, okay, because I is equal to 0 means considering the first element, we are increasing the window size. Then I value increases. I value becomes 1. That means next to three elements it searches, then I value 2, next to two elements it searches, like this it goes. Okay, good. So then for each of I value, then j should add or increment the window value. Okay, so increment window, so that's why j should start from I to n. J should start from I to n. Okay, so for j in range. Okay, right. So what are the j values in this case? J values should be I. So first we have taken I value as 0. So 0 to n. Okay, so 0 to n means n value is 4, no? So it generates 0 1 2 3 values. Okay, so then it adds remaining all the elements of the array. That is the loop. Okay, so now what we do is we'll split this array into two subarrays, one containing maximum subarray. So your maximum subarray is starting from I to j plus 1. Yes or no? Okay, so it is from I to j plus 1. Okay, so what is our I value? this I is equal to 0. That means the first element we are considering. So we are taking the first element. We are working for the first element. Okay, so look at here. So for first element we are looking. So that means our max sub array. Okay, so is minus 10 now. Okay, so how you should get this minus 10 here? See here, it is starting from I to j plus 1. I value is 0 and j value also initially with start with I to n not 0. So 0 colon 1. 0 colon 1 means it is 1 less than. Okay, so that means it is nothing but 0 to 0. A of 0 to 0 means A of 0 element will be stored in this max subarray. So the first element comes here. Then the remaining elements you form in others. So you write others. Okay, so others is equal to, what are others are? Others, you should sort them in a descending order, I said. So you should use the sorted function. So there is a sort function and sorted function. You should understand the difference also. Sort function and sorted function in Python. Sort, if you pass an array to or a list to sort, it will do sorting in place. That means the list will be modified. Okay, if you use sorted function, okay, so it returns a new list or a new array, sorted list or a new sorted array it returns. Okay, so original list, original array will remain as it is, it will not change. Okay, so here we don't want to disturb the original array, we want the subarray to be returned. So that's why we are catching in a variable subarray. Others also we are catching. Okay, so in sorted. Okay, so what are all elements? Sometimes here, if your I value is here, then remaining elements means sometimes it could be all the elements before the I value and all the elements after the I value. Okay, so this side others and this side others will present. Okay, so you should concatenate both of them. You should concatenate both of them. Okay, so first we'll extract all elements towards left, that is from 0 up to I value. Up to I value, for example I is equal to 1 means you should get all the values up to before position. Okay, so that you should write here. So you can write here, it is nothing but a of 0 to, no need to write 0 up to I value. Okay, so left side values you will get here plus, then get all the right side values. So right side values where they are present, they are present. Okay, so where they are present, right side values, they are present from j plus 1 position. Okay, so j plus 1 position up to end. Up to end you should get. Okay, but here what you need to do, this is the all other elements you will get. So they should be arranged in a descending order, I said. No, so for that, if you want to give this then you can say reverse is equal to, okay, so reverse is equal to true, then it arranges the numbers in descending order. If you don't give this reverse attribute, then by default it arranges them in a ascending order. So in this case it is ascending, in this case it is descending order. Got it? Okay, so then we got that means we split this into two sub arrays. Okay, so once you split into two sub arrays, then what you need to do? Okay, so this is your you got these two. No, I'll write here max sub array. Okay, so which is nothing but minus 10 here, and others you got here. Okay, so your others is nothing but remaining elements. Okay, so in this case it is 5 5 minus 10. Okay, so what you need to do, you need to update the current sum. So once you got this max sub array, okay, so current sum is nothing but sum of all the elements in that. So current sum is equal to, just you can pass that sub array to sum function, it adds all of them. Okay, so no need to write any loop, just you say sum max sub array. Okay, so it gives the sum of all elements. Okay, so then your current sum will become a minus 10 in this. Okay, so once you get a current sum value, okay, so then you check whether swap is allowed or not. Swap is allowed or not. Okay, so for that, what you need to do, how many number of swaps you should choose. Okay, so because sometimes we have seen in the example. Okay, so in the example we have seen when all the elements exhausted, there are no elements in others. There are no elements in others. Okay, so then in such case you cannot perform the swap operation, even though it is allowed k is equal to 1, but you cannot perform swap operation. Okay, so that you should decide whether swap is allowed or not. If allowed, it should be 1 only. If allowed, it should be equal to 1. Okay, so that means it depends on a length of this subarray and also length of this subarray and also this value. Okay, so out of these three, whichever is minimum. Okay, so in sometimes what happens, for example, if max subarray contains all the four elements it contains. Okay, so then k value is 1. Okay, so then length of this max subarray will be 4 and others will be 0. Others will be 0. Okay, so in this case you cannot perform the swap operation. Okay, so then to know this, what you need to do, you should take minimum of these three things. Okay, so if you take minimum of these things, okay, so minimum of 1, 4 and 0, then you will get the swaps to perform, number of swaps to perform. Okay, so it could be 0 in this case. For example, you have two elements in this case. For example, in this case, see, your max subarray contains two elements, others also contains two elements. Okay, so then what is the minimum function in this case? It could be k value is 1 here, then length of this max subarray, it is 2 here, then length of others, it is 2 here. So then minimum is 1. So that means it is always either 1 or 0 swaps. That's it, but not more than a k in this case. Okay, so this is how you should use the logic. Okay, so that's why what I do is I uh, check out okay, so how many swaps I should perform. Okay, so number of swaps I'll get. Okay, so it is nothing but minimum of k value comma length of your max sub array. Okay, then similarly length of others subarray. Okay, so whichever is minimum, it takes that value. Okay, if others is 0, then minimum means number of swaps it takes as a 0. That means no swapping allowed in such case. Okay, so once you get a number of swaps here. Okay, so then what you need to do, you need to perform those many number of swaps. Okay, so in this case k is equal to 1, but if k is equal to 2 or k is equal to 3, you need to go on repeatedly swap the values. Okay, so that means all the smallest numbers in max sub array. Okay, so for example, your max sub array contains these numbers. Okay, since our array contains only 4 elements, but the test case may contain array of 100 elements, 1000 elements. Okay, so in such case your others also contain these things. So k is equal to 2. Okay, so 2 times you need to perform these swap operations. Okay, so there are two least elements in this and two highest elements in this, then swap them here. Okay, so that's why you need to perform all these number of steps. So for that we use a for loop here. Okay, so for something like swaps, no, so s in a number of swaps. Okay, so for s in a number of swaps, s value. Okay, so number of swaps is this, you should pass to range function directly. We cannot use like this, so it is range of a number of swaps. Okay, so since in our case it is number of swaps is 1. Okay, so S value will get range of 1 means S value will get as a 0. S value will get as a 0. Only one swap. So that's why always the highest element will present in others at index 0 only. At index 0 only. If number of swaps are 2, then S value may be 0 and 1. So two elements will present in first two positions in this others. Others is in descending order. So always the highest two elements will present in first two locations. Yes or no? Okay. Only those two elements we are swapping in this case. Okay. So this is how it uh, runs the loop. For S in range, number of swaps. S value is 0 in our case. Now what we need to do, whether we need to perform swap or not. How do we check? How do we check whether we need to perform swap or not? Okay. So we'll check whether this others contains greater number than the number in a subarrays. Okay. So number at this 0 index and number at 0 index. Okay. So if this is greater, then you need to perform swap. Now write the logic there. Okay. So what is our logic? That means if others. Okay. So if others of S is greater than max subarray, greater than max subarray of S. Okay. So if others contain a greater value than max subarray, now you need to perform the swap here. Okay. So here directly don't perform the swap here. Don't perform swap. Okay. So logical swap you need to perform. What do you mean by logical swap? That you need to understand. If you perform swap operation, so then it takes enough run time. Your runtime will be consumed. Okay. So anyhow, this is not required swapping of these numbers. Okay. So it is only required the logical way of swapping these numbers. Okay. So how it can be done, just look at here. Okay. So I'll explain here. For example, in this case, so assume that your max sub array, okay, so contains minus 10, okay, then others contains, okay, so in this case it is like a 5 minus 10 descending order, no? So in this case, what is current sum here? Okay, I write current sum is minus 10. Okay. Okay, now we are checking current sum we got here. Number of swaps, minimum of this. Assume that number of swaps is equal to 1. So for S in range means S value is 0. Now we are checking if others of 0, okay, others of 0 is greater than a max sub array of 0. Okay, this since there is only one element, it is at a 0 index. Okay, so 5 greater than minus 10, yes. Okay, so if you swap mathematically, if you swap, what you are doing, you are using that to update the current sum value. Okay, so that means if you interchange these two values, then the current sum value will change here. Current sum value will change here. Okay, so that means if you interchange, for example, there are two elements in this, then in such case, what you need to do, the element which is coming into this max sum, that should be added. The element which is going out from this max sub array should be subtracted. Okay, so that the current sum value will be updated. Okay, so here what you need to do is just logical swapping. This is what logical swapping. Logically, you say that it is, I'll show here. So this is how, if you update the current sum plus is equal to previous current sum. Okay, then the one which is coming inside, this is the element coming inside. Where it is present in others. Okay, so others of yes, it should be added here. Okay, it should be added here. Okay, so then the one going out from this max subarray should be subtracted. Okay, so then you should say max subarray of yes. Okay, so add this element and subtract this element from current sum. It will be updated. Okay, so what happens in this case? Just see here. So current sum is equal to previous current sum minus 10. Okay, so plus others of 0, 5. Then subtract this one. Okay, so minus of minus of what is the element in this? So it is minus 10. Okay, so minus into minus is plus. Okay, so this becomes a plus 10. This becomes plus 10. So plus 10 minus 10 get cancelled. 5. So that means, see here, physically, if we swap what we did, 5 comes here, we said, minus 10 comes here, we said. Okay, then you update the maximum sum, current sum. Current sum is nothing but sum of all the elements, which is 5 in this case. That is what we got here. Current sum value we got here 5 with this statement. Okay, so this way, logical swap, if you perform, your program runs faster. Okay, if you physically, if you swap, then it takes time, so you may get TLE error. Got it? Right. So once we updated this, okay, so what we need to do then, if the condition is true, then it performs this. Otherwise, no swap is involved. So that's why simply in else part, you'll say you break the loop, come out from the loop. This is what you can say. Because since the others contain smaller element, you cannot perform the swap. Okay, so in the first place itself it is smaller, then definitely in the next place smaller than that number will present in others, because you are arranging them in descending order. Okay, so then no use of checking for other numbers, directly you can break. That is the advantage of arranging these others in a descending order. Okay, got? So just you say break. So once you break, then what you need to do, you come out from the loop. Now you update the max sum value. Now you update the max sum value. So now you got the updated current sum value, updated current sum you got. So now you update max sum value. So your max sum, okay, so is equals to maximum of previous max sum, then current sum. Okay, so it is nothing but current sum. It will be updated. Okay, so after coming out from this inner loop, it, okay, so then it goes up to the inner for loop. This j well for loop is there, no, it goes. Okay, so then it checks with the next element. So first it started with minus 10, then it checks minus 10 5 as a one pair, then it checks minus 10 5 5 as one pair. Okay, then it checks minus 10 5 5 minus 10 as one pair. This is repeated for j loop. This is repeated for a j loop. Okay, so once the j loop completes, again it goes to I value. Okay, so I value 0 we have tested in this case. For 0 it checks all this, then I value becomes a 1. Okay, so that means I value is 1. So for this element we are checking. So first it starts with a 5. Okay, so then it combines a next 5, then it combines a next minus 10, like this it checks. Then I value 2. Okay, so for this it checks. So like this, the outer loop repeats for each element, whether there is any sub window. Okay, so that is maximum. So here we required these three loops, and this for loop is for performing number of swap operations. Okay, so once you come out all this max sum contains the maximum sum value. Okay, so if you can return this, so after coming out from this outer loop for all I values, okay, so then you return this. I am just writing here since okay, so what I do is I write this statement here. Okay, so just you can say return max sum. If you can return max sum, okay, so then it returns. Now this is our function. Only this piece of code if you can complete, then that is enough. Is that okay? Okay, so what is the difference between for I in range n and I in n? Okay, so for I in n gives, n is what? N is only an integer number. Okay, so n is only integer number, so it gives error. Okay, so you cannot use. If for loop, what it does is, okay, so it for I in okay, so here it expects a sequence here. You should pass a sequence here. You should pass a sequence can be a list, tuple, okay, a group of elements you should pass. Then from that group it supplies one element to I. Okay, so if you pass a simple number here, n value, okay, so like for I in something like 5, okay, so there is no meaning here. There is no meaning here. Okay, got? So when you say range of 5, when you say range of 5, this range function uh, generates the numbers starting from 0. Okay, 0, 1, 2, 3, 4. It stops up before number, stops at a before number. So 0 to 4 numbers it generates. Okay, you can also give the range function where it should start. Okay, so if you say range 2 comma 5, so start at 2 and stop at one less of this 5, so stop at 4. Okay, so then it generates the numbers like 2, 3, 4, like this. Then I value will get first 2. Okay, then I value will get next 3, then I value will get next 4, like this. One value will be supplied to I. For each I value, then the remaining piece of code will be executed. That is the difference. Got it? So shall we execute this code? So let me go to IDLE. Okay, so I have written this code. Just let me show the execution of this code. Okay, okay. I'll share the PDF. Okay, so in Infosys WhatsApp group, I'll share all the questions. Okay, so PDF, even 2025 Infosys questions also, I'll share the PDF in Infosys WhatsApp group. Okay, so if you are not part of that, just join that WhatsApp group. I'll share all the questions in that WhatsApp group. Okay, so let us execute this. Let us go to uh, IDLE. Okay, so yeah, this is the code. Okay, so whatever we discussed, this is the code. Okay, so here I took length of the array. So if n is supplied here itself, then this n value uh, not required here. So I remove this code, then n you can take here. So let me save this. Okay, right? Yeah, so for this I have shown this in red mark. I'll remove this commenter. Okay, now can you just tell what is the answer for this? Okay, if this is your array and k value is 1. Okay, so what is the maximum sum you will get? Can you just type your answer? Let us verify with our program. So for this first test case, okay, so what is your answer? Just type in chat. Your answer should match with our program. Okay, so after you Give your answer. I will execute this code. Just type your answer. So here array and this one. Okay. So we'll get error. No, here number of elements also. I should pass here. 3 is number of elements. Yeah. What is the answer? Can you just so let us run this code and look at the answer. Okay. So see whether it matches with your answer or not. So let me run the code. Okay. Now you got the answer as a 2. Okay. So since one swap is allowed, this one you can swap with a -10, then you will get 1 1 as the maximum subarray. Okay. So let me take one more example, one more test case. Okay. So it is -5, 10, -5. One swap is allowed here. If one swap is allowed, okay. So what is the answer? Let us run the code. So it is 10. Okay. So even if one swap is allowed, but not required here. Okay. So then 10 is the only positive number in this. Okay. So we will modify this from our example. Okay. So in our example, we took -10, 5, 5, -10. No. So I'll modify this -10, 5, 5, -10. Okay. So then 5, 5 and -10. Okay. So number of swaps allowed 0 we took. Okay. So even 0 or 1 it is allowed. No issue. We'll see. Now here number of elements is equal to 4. Okay. So let us run this code and we'll see what is the answer. Now you can see 10. We are getting the answer as a 10. I'll just keep this in comment so that you can see the output for this case. It is 10. Okay. So even if you keep the number of swaps as 0, still you will get the answer as a 10 because it is at most you may perform, you may not perform the swaps. Okay. And similarly, we reveal for the next test case. So I'll remove, keep this in comment. Okay. So it is 3, 2, -1, 4, 6. Okay. So one swap is allowed. Now if I run the code, now 15 is the answer. Okay. So 15, one swap is allowed. That means if I take this 3 in place of -1, so then this becomes the subarray 6, 4, 3, 2. So which is equal to 15. That is the maximum subarray. Okay. So now this is the code we have written. Okay. So here I have taken float of -infinity maximum. Smallest value I am taking as maximum initially so that you can replace easily. Okay. So when you compare. So just look at the code here. That's it. So if you have any doubts, post your doubts in the comment box of this video. Okay. So thank you one and all. If you feel this video is useful to you, so please like the video and also share the link of this video with your friends so that it will be helpful to them also. And if you are new to this channel, subscribe to my channel for more updates and also click on the bell icon so you'll get all the notifications. And in future, we are going to start after 1 week. Okay. We are going to start data structures and algorithms training using Python. Okay. So the links will be provided. So follow my